Hello students, good afternoon.
Good afternoon, sir.
Good afternoon. So guys, which lecture you had before?
Sir, BYCH. So,
Okay, chemistry lecture you had. So guys, last class we were doing the angular momentum one, right guys?
Yeah.
Okay. So let's first quick revision of the angular momentum part. Oh, 1 minute. So guys, angular momentum में what did we start with first? क्या था? Angular momentum of point mass. Okay, angular momentum of point mass. So L vector, guys, how was the L vector defined? Point mass.
I into
Oh, that was for rigid body na. Point mass के लिए R cross P.
yes.
And और इसका interpretation क्या था? Angular momentum point. इसका interpretation था angular momentum. So angular momentum is equal to linear momentum into, guys, क्या था? Perpendicular distance. Point mass के लिए linear momentum into perpendicular distance, yeah, is also equal to the perpendicular component of linear momentum into distance. वही torque के जैसा. Into distance. Angular momentum. So guys, फिर उसके बाद rigid body के लिए क्या था? Rigid body, angular momentum of rigid body, fixed axis rotation. Angular momentum of rigid body in fixed axis rotation, guys, what was it? L, guys, क्या था? L vector is equal to rigid body के लिए I about the fixed axis into omega.
Yes.
Okay. फिर जो है torque was, guys, क्या था? Torque was dl by dt. ठीक है, torque was dl by dt. फिर इससे जो है important, इस expression से we derived one important concept. What was that, guys? Angular impulse, angular momentum theorem. Correct, students? this से हमने derive किया था. How did we derive? Guys, ये वाला अपने last class में this we have done ना before. This you have copied, right?
Yes.
Yes, Arav.
Yes.
हाँ. So this we had done before. Angular momentum point mass का, angular momentum of rigid body का we have done discussed. Now जो है torque is dl by dt. Now, fourth, yes. So torque is dl by dt. Or say we derived angular impulse, angular momentum theorem, dl. Tau dt is dl. Tau dt is equal to dl vector. Then you integrate this one. Where say we used to get what? J angular impulse is equal to a Li vector, LF vector. LF vector minus Li vector. Where this was guys, ये क्या था? Angular impulse, angular momentum theorem. Okay guys, this was angular impulse, angular momentum theorem. फिर इससे जो है इसको हमने इससे क्लब करके इससे और एक concept derive किया था. What was that?
Conservation of momentum.
Yes, principle of conservation of angular momentum. So guys, ये वाला when you apply this concept, when angular impulse is 0 or
Yes.
torque equal to 0, this we have to ensure either this is 0 or this is 0. Then and only then Li vector is equal to Lf vector. Correct guys, this one we had done.
Yes.
Okay, चलो ठीक है, यहाँ तक तो we had done. अब इसके application part में guys we can apply like application part में ठीक है, जैसे जो है different applications we can do like examples. So let's say the example we take. Suppose we have this एक disk है and disk is rotating about this axis. Angular velocity omega naught. ठीक है, disk of say this is a disk, mass m, radius r. और guys एक identical disk यहाँ पड़ा हुआ है हमारे पास. So we have this identical disk, say identical disk, mass m and radius r. Now this disk is placed on it. So guys, what was the given? Initially it was given that ये disk जो है नीचे वाला white disk is rotating about this axis. Now you are placing this yellow disk on it. दोनों के बीच में there is a friction. Friction is between them disk. Friction is between disks. So guys, जैसे आप उसको put करोगे, eventually what will happen? जैसे ये नीचे वाला disk, ये this was initially rotating with angular velocity omega naught. Both the disks, there is a friction between them. Where then you have placed a yellow disk on top of it. So what will happen guys? यहाँ पर white disk will retard and the white disk will retard or yellow disk will speed up.
Yes.
And they will have some common angular velocity omega. How will you find this angular velocity omega guys?
The conservation of.
Yes, like which concept are we going to use? Principle of conservation of angular momentum.
Yes.
Okay, you want to use principle of conservation.
Because the force will be impact.
Okay, principle of conservation of angular momentum you want to use. Okay. So इसमें जो है first you have to उसको apply करने से पहले what you have to ensure? Torque is 0.
Yes.
So guys देखो क्या होगा उनके बीच का force friction एक पे internal force हो जाएगा.
Yes.
Friction will become internal force और opposite directions में हो जाएंगे. Internal force मतलब opposite directions. So उनका torque net about axis will be equal to 0. So torque net is 0. That means जो है you can then you can conserve angular momentum. Then angular momentum is conserved. Initial angular momentum of the system is equal to final angular momentum of the system. Guys, initial angular momentum of the system कितना होगा? Initially the white disk has
MR into omega naught.
yes, I about the fixed axis into omega. So because
Yes.
rigid body का moment of inertia fixed axis rotation में is this one, I about the fixed axis into omega. So yes, Aditya, what will be the I about this white disk about the fixed axis? This is the fixed axis. Rigid body का I about the fixed axis. White disk. Yellow disk का तो कुछ है ही नहीं into omega. Yellow disk का तो 0. It was at rest.
MR square by 2.
Yes, this mr square by 2 into omega naught plus 0. Or finally they are rotating with a common velocity, angular velocity omega. So दोनों का आएगा mr square by 2 omega plus mr square by both are identical. So guys, इससे कितना आ जाएगा omega?
Yes.
ओमेगा की वैल्यू गाइस कितनी आएगी इसमें?
2.
ओमेगा by 2, omega naught by 2. Okay.
Yes.
So final angular velocity is omega naught by 2. Aryan, you all understood? Ansh?
Yes, sir.
Okay. And इसमें if they ask you to find loss in kinetic energy, guys, कैसे calculate करोगे loss in kinetic energy? If they ask you to find loss in kinetic energy of the system, loss in kinetic energy system का, if there is a loss मतलब कौन सा ज्यादा होगा, initial या final guys? ये वाला initial will be more. So kinetic energy initial system minus kinetic energy final system. Initially only the first one has kinetic energy, or kinetic energy of rigid body fixed axis rotation क्या होगा? Half I will be how much? mr square by 2 omega naught square minus finally दोनों डिस्क का आएगा half mr square by 2 omega square. ऐसे दो हैं, so 2 times. Correct guys?
Yes.
Okay, हाँ. Aditya, this one understood now?
So can you hear? Yes, sir.
Yes, Aditya. हाँ. Soumya, understood this one?
Yes, sir, understood.
Okay, हाँ. So यहाँ पर kinetic energy जो है half I omega square करके initial and final. Initially only the white disk had. Finally दोनों का common angular velocity है omega naught by 2. उससे you can calculate. So इसमें we have ensured that torque is 0 about the axis, no external torque, hence the angular momentum of the system. System में तो दोनों का combined is 0. Done, guys. This one, okay. Students, everybody copied. Nanj copied this one. Vatsal.
Yes.
Okay. Okay.
Yes.
अब जैसे मान लो, let's say similar equation we can try. Let's say we have a bigger disk, and say this is the axis. इसका mass 2m, radius is 2r, और ये angular velocity omega से omega naught 2 omega naught से इस एक्सिस के अबाउट, इस रॉड के अबाउट से ये रोटेट हो रहा है. फिर जो है वी हैव अनदर डिस्क, मास m, रेडियस r, एंड नाउ से जो है जैसे ये वाला अपोजिट सेंस में ओमेगा नॉट एंगुलर वेलोसिटी, ऑपोजिट सेंस. So opposite to the bigger one, opposite to the bigger disk, opposite to 2 omega naught. Now it is placed on it, and eventually both of them they rotate with a common angular velocity, say omega dash. So guys, how will you find omega dash? This way they have placed, there is a friction between them. So there is friction between them. Both disc surfaces are rough.
So we can do the same way we did for two bodies and
Correct. So we'll do the same thing for two body. So finally, say they rotate with common angular velocity, say omega dash. So we'll about this axis, we'll say about this axis, friction का forces will be internal, net force 0, इसलिए torque भी 0 हो जाएगा. इसलिए we can conserve angular momentum of the system initial, final. Initially, yes guys, initial angular momentum क्या लिखोगे? डिस्क का 2m 2r का whole square by 2 into 2 omega naught, and दूसरा वाला is in opposite sense, इसलिए minus m r square by 2 omega naught, और finally 2m 2r का whole square mr square by 2 mass radius square divided by 2 into omega dash plus mass radius square by 2 into omega. Both are moving with the common velocity of omega dash. And now you have to find omega dash in terms of omega naught.
so 15 by 9.
15 by 9. Okay. 15 by 9 omega naught. Okay. Anya, answer is matching na, same 15/9.
Yes,
Sayur,
sir.
matching na, okay. Okay guys, फिर जो है, say if you have copied guys, I will go to the next slide. Okay. So next one, जैसे say now let's take examples on collision, angular को, ठीक है? तो इसमें जैसे suppose we have this rod, से एक rod ऐसे रखा हुआ है, a rod of mass m. So this is a rod of mass m, length L. Rod का mass m, length L. And say there is a particle, यहाँ पे particle ऐसा आ रहा है. Particle is also of mass m, speed v0. Speed v0 से आ रहा है and ये point पे strike कर रहा है. And this point is at a distance. ये topmost point है, ये hinge है, and this is 3L/4 below. This point पे it is striking. Coefficient of restitution, ठीक है? So say E is equal to say 0.5. कुछ ले लेते हैं, कुछ 0.5, some 0.5. E is equal to 0.5, 0.6, whatever. So after collision, immediately after collision, so immediately after collision, find the speed of particle and find the speed of particle and angular velocity of rod. Speed of particle and angular velocity of rod. Angular velocity of rod. So yes guys, this is initial, this is the initial diagram. ये initial हो जाएगा. And this is just after collision. So guys, just after collision में unknowns क्या क्या रखोगे? What unknowns you are going to keep? Just after collision.
The speed of the
Yes, speed of the particle, say v1, हाँ, and second unknown,
and rod
angular velocity of the
angular
rod.
velocity.
So these are the two unknowns. अब guys solve करने के लिए you need two equations, two concepts. Which are the two concepts guys यहाँ पर? Which are the two concepts which you are going to use?
So both.
Which one are immediately after collision we want to find? Yes, Arav, Ansh, which are the two concepts which you'll use to form two equations?
So linear
Momentum. Okay, you want to use linear momentum conservation. Okay, first and second one.
So the restitution formula.
Okay, the first one you want to use linear momentum conservation. Concept one. Linear momentum conservation. And second one is second concept restitution. Okay. Restitution equation. Okay guys, ठीक है. Arab linear momentum conservation, before applying linear momentum conservation, what we have to check? पहले तो किस पे apply कर रहे हो? Rod पर, particle पर, या system of rod and particle?
So System.
System. Okay. So you want to apply linear momentum of the system, and direction also, which direction?
X.
X direction. Okay. So before applying conservation of linear momentum next direction, what checks you have to do?
The forces.
Net force is 0. Okay, net force 0, yeah, impulse is 0. So x direction में force या impulse is 0.
Yes, equal normal reaction.
X direction में force, okay, हाँ, इन दोनों के बीच का reaction force वो तो internal हो जाएगा, right? Like this.
Yes.
Aryan, is net force 0 on the system in x direction?
No,
Right. No, why not?
because there is no opposite force.
No. There is no opposite force. So net force is 0. You are saying?
No, it's not 0.
Oh, not 0. Which force is there? The force by where is the force in x direction?
No, there's no force. Yeah, so it's 0.
There is no force, you are saying. Okay, Ansh. So do you agree? Sarthak, do you agree? Keshav,
I didn't hear what Aryan said.
you agree with what Aryan has said? Net force is 0.
Yes, sir.
Okay, your answer, you agree. Yes, Avanti, net force is 0 in x direction on the system of rod and particle. Soumya, Utkarsh, Vatsal, Aditya, Anya, net force is 0 on the system of rod and particle. So they are Arav.
So what is the omega acting type?
Force net. No. Aditya, I was asking about force. Like force is
Okay.
0 on the system of rod and particle. Net force in x direction is 0. Yes, Anya, is it 0?
So the velocity constant.
Velocity is constant, but Aditya, the question still remains the same now. Like force, you're not telling. Akshat, like force is like 0 or not when we take both of them as a system.
Sad collision.
Collision.
Like at the right after collision, the force is 0.
Okay, during the collision, you are saying the force between them will be internal. So इनके बीच का force जो internal हो जाएगा, you want to take, we are taking them as system, so their force will be 0.
Yes.
Astha, yes. What is your answer? Yes, guys. Sabojit, yes, huh? Oh, Arav, you are missing this point now. See, this is a hinge. So hinge ka reaction Rx and Ry may come.
Yes.
If Rx and Ry are there, if Rx is there, I don't know Rx is there or not, but if Rx is there, then momentum you cannot conserve.
Yes.
Correct. So it's like same thing.
Angular momentum can be.
So this linear momentum conservation is not correct. So yes, third concept. Yes, Ara. Which one is third concept? Angular momentum.
Angular. Yes.
Okay, so you want to conserve angular momentum. So angular momentum conservation kiska system ka?
System.
Okay, about which point? About
the hinge.
Yes. So when you take angular momentum conservation about hinge, what you are doing is you are ensuring that even if there is Rx, so torque of Rx is 0 and torque of Ry is also 0. So these are the two concepts which you use. correct? Okay. So that means angular momentum, linear momentum we don't know. So angular momentum, yes, we can conserve. So okay, angular momentum conservation, we'll do first one. Okay, first concept, angular momentum conservation. Initial angular momentum of the system is equal to final. और किसके about लिख रहे हैं? About hinge. Initially, yes. So now you have two objects. One is point mass, other is rod. So initial angular momentum किसका आएगा? Rod was stationary, so initially rod का कुछ नहीं आएगा. Particle का आएगा. Guys, particle का कितना होगा? Yes, guys.
So,
Particle का. What is the linear momentum of a particle? Linear momentum into perpendicular distance.
arc
Yes. So linear momentum into perpendicular distance. So how
Yeah.
do you write linear momentum का line of action? ये हो जाएगा line of action. इस point के about निकालना है.
3L by 4 into
Okay. So mv naught linear momentum into perpendicular distance 3L by 4 plus rod का तो 0 है. Finally, yes guys, final just after collision. Again, particle का तो है, particle का speed has changed mv1 into 3L by 4
and
plus
rod का fixed axis के about I omega.
I, yes, fixed axis rotation, I about the fixed axis. What will be the I about the fixed axis? I
So
about
rod ml square by 3.
fixed axis happens to be at the end के about ml square by 3 into omega. Okay, this is the first concept. से एक equation ही आ गया. And second one, restitution equation, E is equal to V relative separation divided by V relative approach. So E is 0.5. Relative velocity of approach. Guys, restitution equation कौन से direction में लगाते हैं? At the point of contact, along the line of impact?
Yes.
Restitution equation must be written along the line of impact. Line of impact ये वाला direction होगा भाई. इस point, ये point mass का और rod के इस point का interaction हो रहा है. Rod का ये point और ये point mass. So this will be the line of action. Okay, initially this point is at rest. So what will be the relative velocity of approach? V naught. So V naught minus 0. अब guys ये बताओ, जैसे collision हुआ इसके पास angular velocity आ गई तो इसकी speed कितनी हो जाएगी? इस point की speed omega r.
Yes.
So omega r, omega into 3L by 4. और इसकी V1 है, relative velocity of separation कितना हो जाएगा? Omega 3L by 4
minus V.
minus V1. So you have guys two equations and these are the two unknowns. यहाँ से solve easily you can do. M cancel हो जाएगा, mass is same, length भी एक L कट जाएगा. And you can you have two equations to solve simultaneously for V1 and omega. Guys, you all understood?
Yes.
Okay. And if they ask you to find loss in kinetic energy of the system, so same during collision. So you can find initial kinetic energy, you can find final kinetic energy. Kinetic energy, you know, particle का लिखना आता है, particle का हो जाएगा final half mv1 square. rod fixed axis rotation, kinetic energy half I about the fixed axis into omega square. That also you can write. Correct, guys?
Yeah.
Huh.
Yes.
So guys, this one done, copied.
Yes.
Okay. चलो भाई फिर जो है we can have another example. जैसे let's say we have same ये ले लेते हैं. Suppose ये rod. So say we have this rod of mass m, length L. ये rod of mass m, length L. And say there is a particle यहाँ mass m, same mass, speed v naught. और ये यहाँ पे strike कर रहा है और particle sticks to it. So यहाँ पर it is given that particle sticks to the rod. So particle sticks to rod. तो ऐसे ये particle इसमें stick कर गया. So that means now you just have to find stick कर गया तो then इसका motion क्या होगा? Rotational motion, pure rotational motion only. Fixed axis rotation motion. ये तो रेस्ट पे था initially और इसकी ये निकालना है. Particle sticks to the rod. So guys, how will you find after particle sticks to the rod the angular velocity omega? Just after collision, just after particle sticks to rod, find omega.
So same method and E will be 0.
Correct. Same method. E is equal to 0. So guys, यहाँ पे एक ही unknown है. So एक concept से काम हो जाएगा. Which concept?
So conservation of
Yes. Conservation of angular momentum. Linear momentum नहीं होगा क्योंकि hinge का force है. Angular momentum. So conservation of angular momentum. Initial angular momentum of the system. This is the initial picture. And this is the final. Initial is equal to final. Yes guys, initial angular momentum किसका आएगा?
so particle.
So only the particle will have initial angular momentum, which will be equal to linear momentum into perpendicular distance. Perpendicular distance कितना हो जाएगा? इसके edge पे strike कर रहा है.
L.
L. And rod is at rest. So 0. Finally, yes. So guys, finally, now it has become one rigid body into omega I about the fixed axis into omega I. Now moment of inertia of this system about this hinge. System में क्या क्या है? Rod. तो rod का how will you write? ml square by 3I. So this is I about the fixed axis into omega. I में एक rod आया and दूसरा particle का ml square. So इससे omega. So guys, this one done. What is the answer? M to cancel हो जाएगा. Yes. One L will go away. So how much it is the answer? 3B by 4 क्या?
Yeah.
3V by 4L. This one is correct na guys, ये वाला?
Yes.
Okay. So if you have copied, we'll go to the next one. Last wala, everybody had copied na guys, ये वाला?
Sir, I had a doubt.
Yes, please ask.
Sir, here, when you wrote ml square by 3, that was for the rod. And why did you write ml square?
Oh,
Plus.
see. Okay, 1 minute. This is for the 1 minute. This is for the rod. I about the axis, the rod, and the particle is now stuck here.
So shouldn't it directly be 2 ml square by 3?
Oh no. See, we have to find the moment of inertia of this object. This object is made up of one rod and one point mass. So rod का हो जाएगा ml square by 3 और point mass का तो m into l square.
Okay, sir.
Correct, huh? So this is for the rod. One is the rod and the other one is the particle. Rod and particle. Okay. Okay, guys. Next, Yola, how will you do? For bead of mass m, only the velocity v gets threaded on a stationary semicircular ring of mass m radius r. The ring can rotate freely about its center. O is the axis. The bead comes to rest relative to the ring. Finer angular velocity of the system. Yes, guys, कैसे calculate करोगे? Which concept?
Conservation of angular momentum.
Okay, conservation of the angular momentum. Conservation. Because जो भी guys यहाँ पे भी जो है, see जो भी force होगा दोनों के बीच का आपस का internal हो जाएगा और इसी के about conserve करेंगे तो इसका जो है इसका force आएगा लेकिन torque नहीं होगा. इसलिए जो है net angular momentum यहाँ पे हमने conserve कर दिया about hinge. यहाँ पे जो है will conserve conservation of angular momentum. So conservation of angular momentum about the hinge. जो भी hinge के forces हैं उनका torque 0 हो जाए. So we'll write initial angular momentum of the system is equal to final angular momentum of the system. Guys, initially किसका आएगा? Angular momentum of the system, point mass. So what will be the angular momentum of the point mass? Initial angle. This is the line of action of the point mass.
M.
Linear momentum into perpendicular distance from the hinge. So guys, क्या होगा? MVR. Finally, I of the new object formed. I of the new object which is formed because it new object formed fixed axis into this is the fixed axis about fixed axis obviously fixed axis O into omega okay. Yes, so guys क्या क्या होगा पहले तो लिखना पड़ेगा भाई semicircular ring का कितना आएगा moment of inertia about this O. Semicircular ring का हाँ yes how much Arav?
So mr
square
by
mr square by 2. Mass of the semicircular object is m. Yes, Aditya, what will be the moment of inertia of this semicircular ring? The moment of inertia of semicircular ring. Yeah, Vatsal, yes, Soham, Shlok. Soumya, what moment of inertia? Please tell.
The MR square.
MR square only? Why MR square? How will you explain this MR square? Why it is MR square? Yes, Arav, you're right. How will you explain?
So the way we did this
Ah,
R into dx.
like this is a like see Arav, ये तो जो है semicircular ring हो गया, ऐसा था ना, right?
Yes.
और यहाँ पे particle आ रहा है और उसको strike कर रहा है. Right? This is the isometric view of this arrangement.
Yes.
So इस semicircular ring का all the particles, सभी particles का distance कितना हो जाएगा? All particles are at distance r ना? Say if
Yes.
all particles are at distance r, moment of inertia will be how much? Simply mr square. ये हो
Yes.
गया आपका semicircular ring. Semicircular ring. Semicircular ring या circular ring, all particles are at distance r. So सबका r है तो सबके dm का sum करोगे, it has to be m. All particles का distance is r will come out of the integration. और point mass का कितना होगा? Point mass तो यहीं पे जाके stuck हो गया. So point mass का तो mass into distance square.
Yes.
Okay, तो इससे ओमेगा की वैल्यू कितनी आएगी?
So V naught V naught by 2 MR square.
V naught
V
by
naught 2 R square.
V naught by 2r. Okay. Guys, you all everybody understood? Sayuj?
Yes.
Okay. Aryan?
Yes, sir.
Huh. Diagram understood ना guys? ये कैसा था? This was the ring here, free to rotate about this axis. This is the top view. ऊपर से देख रहे हैं? ऊपर से देख रहे हैं तो ये वाला ring ऐसा दिखाई देगा. Axis will look like a point. This is the isometric view. ये particle जाके उससे strike कर रहा है. तो initial angular momentum final में जो है I into omega. Students, you all copied everybody?
Yes, sir.
Okay. Yes, guys. इसका diagram explain करो पहले. Guys, इसका diagram please explain. What is the diagram here?
So first will be a hollow tube.
We have a hollow tube. Okay. हाँ. एक hollow
Then
tube
through
है.
the axis.
Yes, through the hollow tube there is a string passing through it. हाँ.
So and through the passing to the axis, and there's a object like attached to the string.
The object is small object is attached to a light string which passes through a hollow tube. Okay. हाँ.
So and then it's rotating with a circle of radius r1 inside.
Okay. हाँ. So मतलब आरव ये हॉरिजॉन्टल प्लेन में ऐसा कुछ होगा क्या, राइट? Like this is a say this is an imaginary plane और ये ट्यूब के अंदर है, मान लो there is a hollow tube here
Yes, yes.
और उस पे there is a यहाँ पर this is rotating, so this is the axis and इसके about से it is rotating. Initial radius is r1 और guys यहाँ पे मान लो there is a यहाँ पे hole से नीचे ये string और say ये this is some person's hand और person जो है इसको ठीक है, person उसको नीचे जो है पुल कर रहा है. So person उसको नीचे पुल कर रहा है, स्ट्रिंग को पुल कर रहा है, तो ये रेडियस is getting shortened to radius r2. Radius is decreasing now. Okay. Say इसका initial angular velocity was omega naught. So I am assuming this tube as massless. Okay guys, फिर कैसे करेंगे इसको? Yes sir. Finally अब जो है ये r1 था, फिर उसको आपने शॉर्ट कर दिया, रेडियस r2 हो गया. So how will you attempt this question? Yes guys, how will you attempt this one?
So about fixed axis, the
About this
we
fixed
can-
axis, about this fixed axis. Okay, fixed
we
axis.
can
Huh?
find the kinetic energy.
Okay, you can find the initial kinetic energy. ठीक है भाई, initial kinetic energy will be half I. Point mass है, point mass का moment of inertia will be mr1 square into omega naught. Okay, this is the half, नहीं half क्या होता है? Half I omega square होता है. Okay,
Yes.
half I omega square से लिख लो तो कितना आ जाएगा? ये वाला value will be m/2 और r1 omega naught का square. मतलब half mv square guys, point mass का, correct ना? Half mv
Yes,
square.
sir.
Same thing. Okay. अब how will you find the final angular velocity? जब ये person नीचे खींच रहा है इसको, इसका radius decrease हो गया. So when radius decreases, how will you find?
So same thing except r1 की जगह it will be r2.
But angular velocity will change or not. It is not given that the body is tube is rotating with a constant angular velocity. तो जैसे ही नीचे खींचोगे उसका angular velocity change जाएगा.
Yes.
So how will you find the new angular velocity? Which concept?
So conservation.
Okay,
Angular.
conservation of angular momentum about which point?
So the fixed axis.
About fixed axis. Okay. So torque zero, torque of string at the torque of tension will be zero because tension will be passing through this axis. So torque of string tension is zero. So initial angular momentum is equal to final initial angular momentum. Guys, कैसे लिखोगे initial angular momentum? Point mass का mvr, mvr. R is r1, velocity क्या लिखेंगे? Omega naught r. Finally, mv r2. V को क्या लिखोगे? The new angular velocity omega dash omega f into r2. ये mass हो गया यहाँ से. So guys, how will you? What will be the new angular velocity? Omega f will be how much? Omega naught
So omega r1 square by
r2 square. So kinetic energy final कितना हो जाएगा फिर? Half m v2 square. v2 कितना हो जाएगा? Omega f r2 का
yes.
square. मतलब m/2 omega f square r2 square. तो वैसे ये कितना जाएगा? Omega f square r2 square will be how much? m/2
Omega. So same as omega r1 square by r2 square. Oh, sorry, omega r1 square r2 square.
इसकी वैल्यू पुटअप करेंगे तो लेंदी टर्म आएगा ना. ओके, क्या क्या जाएगा? m/2.
So R2 square cancel.
ओ, तो ओमेगा f square r2 square. हाँ, in place of omega f square, what you'll write? Omega naught square.
Omega not R1 square.
R1 to the power 4, R2 to the power 4 into R2 square.
Yes.
सर, अब इसका रेशियो लेना है. ये काइनेटिक एनर्जी, न्यू काइनेटिक एनर्जी और ये इनिशियल काइनेटिक एनर्जी, इसका रेशियो लेंगे तो क्या आएगा? m/2 कैंसिल, ओमेगा नॉट स्क्वायर बाय 2 भी कैंसिल,
So R1 square by R2.
R1 square by R2 square. Okay. So R1 square by R2 square. Answer, guys, matching now. Please check.
Yeah.
Okay, okay. Since Yola, everybody understood this one? Please ask if any doubts here. 1 minute. So guys, this one copied now.
Yes.
Okay, okay. ये वाला तो, this is R. Look, this is R2 to the power 4. R2 to the power 4. Okay. Oh, sorry. Yes, guys, इसका क्या होगा?
So PF minus P.
Oh yes, yes. How are you doing this one?
So PF final mass minus PH.
Okay, so you're 1 minute. This is exercise 1 booklet. Guys, centripetal force is 9. Yes, हाँ, centripetal force को कैसे use करेंगे? Is how much?
Square.
Yes,
mv
mv square by r. Okay. mv square by r. This is given as point. This is 9 Newton. Okay. So mass is 1/2. V square r is 2. So इससे v की वैल्यू कितनी आ जाएगी? 6. and you want to find angular momentum. Angular momentum कितना हो जाएगा इस circular motion में? Angular momentum about center निकालना होगा. क्या हो जाएगा? Linear momentum into perpendicular distance, MVR half into 6 into 2. Correct guys, ये वाला?
6.
Okay. Yes, ये वाला everybody understood this one?
Yeah.
Okay. Next, this one, HCV. So this is a wheel, it is rotating. And there is a stationary particle like this. और ये जो है इसके edge पे आ जाता है. And finally, initially only the disk was rotating, and finally abhi they will rotate together. Omega dash, new angular speed. Yes guys, which concept you are going to use?
The one we did in the first student.
Correct, huh? So,
Conservation of linear angular momentum.
conservation of angular momentum, yes, correct guys. Yes guys, से निकालो आंसर कितना आ रहा है? So initial angular momentum system, final. Initially किसका होगा? Wheel का होगा. Wheel का given है. Wheel का I ओमेगा particle का rest पे होगा. Finally I and particle का it will be m into r square
R.
into omega dash. This I is given 0.5, angular velocity 20, 0.5 plus stationary particle of mass 200 grams, so 200 by 1000, radius 20 centimeter, 20 by 100 का square into omega dash. So guys, omega dash कितना आ रहा है?
So 19.68.
19 point how much, Arav? 19.6 radians per second. Answer matching now, this one, HCV 51. Anya, answer is matching. Aditya, Ansh. Yes, Atre, please check answer if matching or not. Ratmesh. Okay, guys. So if you have done, I will go to the next one.
Yes.
Okay, sorry. Yes, guys. इसमें कौन सा concept आएगा यहाँ पर? Omega dash we want to find.
Conservation of linear
Conservation of angular
angles.
momentum.
Angular.
So yes, this is a rigid body. So ठीक है, I1 omega 1 equal to I2 omega 2.
Yes. 6 into
Initially
2 is 6 into 5.
6 into 2 is equal to 5 into omega dash.
Yes.
Huh.
So 2.
Okay guys, ये वाला भी हो रहा है. फिर जो है
So same.
same
Conservation
angular
of angle.
conservation of angular momentum. Yes guys, get the answer.
Six into 120 by
Arab answer is matching now.
yes.
इसका okay. इसमें guys yes, what is the solution जो है oh 6 initially 6 है ना. हाँ.
Yes. Initial
Okay.
into omega not.
So I initial omega initial is equal to I final omega final. What is the initial I? 6 no?
Yes.
And initial
Yes.
omega is 120 RPM.
Yes.
Final is 2 और इसमें निकालना है omega dash RPM.
360 RPM.
Okay, so this omega dash is 360.
Yes.
360. Okay. Okay, guys. Then next one. Oh, sorry, this one everybody had copied now, guys. Wala. Okay. So guys, see, this is a platform, boy, or ये एक system हो गया, and they have an umbrella. Okay. So initially all are at rest, or finally platform और boy एक side जा रहे हैं और umbrella दूसरे side पे आ रहा है. So this is omega 1, ये वाला omega 2. Yes guys, how will you do this one?
So initial moment of inertia will be
Like
three
our concept will be this one, and initial is equal to find. So initial will be how much? What is the initial angular momentum of system?
So 3.0 to 10 to the power minus 3.
No, initially everybody is at all are at rest. The boy holds an
yes.
boy. हाँ, initially one ठीक है, एक rest, सब rest पे है. फिर बाद में जो है एक side when the boy starts rotating umbrella और जो है वो एक sense में rotate होगा तो दूसरा क्या होगा, opposite sense में जाएगा. So क्या लिखोगे, I of boy plus platform, अगर इसको पॉजिटिव सेंस लेते हो, into omega 1, तो अम्ब्रेला वाला नेगेटिव होगा, I of umbrella into omega 2. Okay, now what is the I of boy plus platform?
3 into 10 to the power minus 3.
3 into 10 to the power minus 3, and omega.
So omega will no value.
The boy starts. Okay, the boy starts spinning.
So relative
the
velocity
umbrella.
of umbrellas.
Oh, it's relative velocity दिया हुआ है.
Yeah.
यार दोनों opposite में है.
Yes.
तो relative velocity अगर जो है मतलब दोनों का sum क्या हो जाएगा, 2, right?
Yes.
Opposite. So if this is omega, this will be how much? 2 minus omega?
Yes.
देखो relative में क्या होगा, angular velocity जब opposite sense में तो relative when you're going to take relative they will add up. So if the actual values are say omega and 2 minus omega, they will add up because relative velocity में when we are asked to find relative velocity and they are moving in opposite sense, so 2 हो जाएगा. So that is correct what they have given. So boy plus platform का calculate करना है. Find the angular velocity imparted to the platform, omega minus I of the umbrella कितना होगा?
2 into 10 to the power minus 3.
2 into 10 to the power minus 3 into 2 minus omega.
Yes.
So guys, कितना आएगा इससे answer? You want to find omega.
So 4.
How much? 4.
Yeah.
Omega is 4. No, 2 से कम होना चाहिए.
Oh,
No. Omega is 4. नहीं, फिर गड़बड़ हो जाएगा. 2 से कम होना चाहिए ना? Because one is omega, the other one is 2 minus omega. दोनों का sum must be 2. Something wrong क्या? कुछ calculation है?
yes, no, sir.
Okay.
So 4 by
How much? 4 by
5.
4 by 5. Please also check the answer. Ansh, answer क्या रहा है इसका? Four by 5. Arav matching the answer.
Yes, sir. Checking on.
Okay. Next guy is 55. Anya, answer is correct now. 4 by 5.
Yes, sir.
Okay. Next 55th वाला try करो.
So conservation of angular momentum.
Conservation of angular momentum. Correct. हाँ.
So initial.
Yes, Arav, what do you think?
Yes,
So इसमें जो है rotating इतना second wheel is set into rotation and is coupled to the same shaft so that both the wheels they are in the same shaft, same rotation. So rotation same है. So angular momentum of the system initial equal to final. Okay, initial angular of the system, final angular. Initially, the first disk I1 omega 1 and the second उसका भी कुछ rotation I2 omega 2 and बाद में they will rotate with the common angular speed. So both are rotating with a common angular speed, say some omega. So I1 omega plus I2 omega. निकालना क्या है इसमें? You want to find I2. Yes, guys, you want to find I2 here. You can same I2 जो है उसको revolutions per minute में रखो. तो
yes.
This is 0.1 और ये वाला 160 plus I2 300. I1 is 0.1. Angular speed is final वाला 200 है. Plus I2 200. So you want to find I2. Some kg meter square.
So 0.04.
0. How much?
0.04.
0.04. Okay, 0.04. ठीक है. Next one. Oh, okay.
So same conservation of angular momentum.
Correct. Huh? So velocity of the ball is v naught horizontally along a tangent, or फिर जो it was caught by the kid. Find the angular speed of the platform. Okay, combined. Okay.
So the initial will be mv naught r plus mi square mr square.
Initially
Right.
जो है देखो initial system में सिर्फ ball था, ball move कर रहा था, और finally so this kid holds the ball, or finally they'll all move together with the common angular speed omega dash. Yes.
So initial was mv naught r.
Initially only the ball has angular momentum, so
Yes.
point mass का angular momentum, you know, linear momentum into perpendicular distance.
Yes. mv naught r.
So per m v naught r, और बाकी सब रेस्ट में थे तो 0. Finally, yes, finally they become one rigid body. तो rigid body पे क्या क्या आ जाएगा? I में एक तो हो जाएगा आपका प्लेटफॉर्म, फिर किड का कितना हो जाएगा mr स्क्वायर, फिर बॉल का भी mr स्क्वायर into the omega dash. Aryan, you all understood? Aryan, इसमें any doubt, please ask. Oh guys, you all are not understood क्या?
समझो.
Understood.
Okay, okay. Aditya, guys, everybody understood this one? देखो, please
Yes,
ask. Sarthak, Soumya understood now this one?
Yes, sir, understood.
Okay, okay. Sir, okay. Where next one, guys? So now what you have is so now you have the platform. This is the platform here, kid, and with a ball in the hand. Okay. Now it is at rest. Omega is 0. Initial is 0. Then now the kid throws it tangentially. So guys, अभी final वाले में omega initial, final वाले में the kid now throws it tangentially here, this side, with a speed v as seen by his friend. Friend is on the ground, that means speed is v naught with respect to ground. तो जैसे ही वो पीछे थ्रो करेगा उसकी वजह से गाइस ये किस साइड जाएगा गाइस? ये वाला
opposite.
ऑपोजिट सेंस में इसका रोटेशन होगा. ओके, लाइक दिस. So disk का rotation opposite sense में होगा. So you want to find the angular velocity with which the platform and the kid starts rotating. Okay, this omega dash you want to find. Yes, guys, how will you find this one?
Your conservation of
Conservation of angular momentum, yes.
इसमें it will be the ulta of the three.
Yes, sir. Angular momentum conservation, the axis care about obviously.
Yes.
Yeah. So what is the initial angular momentum?
0.
Initial angular momentum, final. Initial is 0. अब final अगर बॉल का नेगेटिव लेते हो -mv0r, सो इसको तो प्लस में आ जाएगा, अपोजिट सेंस में जा रहा है. और ये कौन कौन है? ये तो प्लेटफॉर्म, यस, प्लेटफॉर्म प्लस किड ओमेगा डैश. This is for platform and this is for kid. Aryan, you all understood now? Aryan is not there now. Okay. Vatsal?
Yes, sir, understood.
Okay. So हम ये लाया ना. Okay, guys. So if you have got this one, next one.
So same conservation.
Conservation of the angular momentum, जैसे इसमें ये सारा ये वाला जो है.
So in the previous one, instead of adding, we will subtract.
करेक्ट. हाँ, ये ऑलरेडी एंटी क्लॉकवाइज में घूम रहा था और फिर जो है, now the kid doesn't have a ball in the hand. ये दोनों ऐसे जा रहे थे. अब now kid starts walking with a speed relative और उसी डायरेक्शन में जा रहा है relative. Okay. अब मान लो उसका एंगुलर स्पीड चेंज हो गया, से ओमेगा डैश, और किड इज वॉकिंग विद द स्पीड ऑफ सम v1, उसी सेंस में v1. सो relative speed is, they have given relative speed as some v0, say this is v0. So we can write relative speed. कैसे निकालोगे? इस पॉइंट का स्पीड हो जाएगा v1 और ये माइनस ओमेगा डैश r is v0. रिलेटिव सेम डायरेक्शन में तो सब्ट्रैक्ट करेंगे. करेक्ट गाइस, सेम डायरेक्शन विल सब्ट्रैक्ट. So this, when you subtract, this is v0. v1 minus omega dash r is v0. Find जो है initial angular momentum is equal to final angular momentum. Yes, guys, try the conservation, get the answer.
So I of platform plus I of kid into omega naught is equal to 0.
Matching.
Yes.
So इसमें अगर V वाले क्वेश्चन के लिए इनिशियल एंगुलर मोमेंटम में क्या हो जाएगा, I ओमेगा नॉट, किड का क्या आ जाएगा, m r स्क्वायर ओमेगा नॉट, और फाइनली I ओमेगा डैश प्लस किड का कितना हो जाएगा, m v r, वी कैन राइट, सो m v r, v is v1, r is some r, और v1 की जगह वी कैन राइट नो, v1 is equal to v naught plus
Omega.
omega dash r. Yes. So this v1 you can put here, or now you can
Yes.
find omega dash. Now guys, this one is 62.
Like conservation of
Conservation of angular momentum. Okay.
so light rod मतलब we have to neglect
Massless.
mass. Yeah.
Yes, massless you can take.
So initial will be the the momentum
the-
of the two balls.
Yes, angular momentum of the two particles, two balls only. Yes. Yes, guys, इसका जो है तो initial angular momentum is equal to final. Initially balls का आएगा, so it's like each ball is at a distance L by 2, no?
Yes.
Okay, okay. So m L by 2
By 2.
square or plus 2 times हो जाएगा, basically they have two balls.
Yes.
So 2 times ml square, और इसका जो है angular velocity is omega naught, initial angular velocity. Then finally m L by 2 का whole square 2 times plus now another particle n, वो stick कर गया ball पे, and ball is at a distance L by 2 only. So ml by 2 का square or into omega dash. So omega dash you want to find in terms of omega naught.
So 2 by 3 omega.
2 by 3. Okay. It's matching the answer, this one.
Yes.
Okay, okay. So see, all everybody understood. Anya, so you start. Aditya, please ask. Sir, मुझे any doubt? Please ask. This one done na guys, see wala.
Yes.
Okay, next this one. So guys, this delay take 2 minutes. I will do that one. So try something.
Okay.
Yes, guys, how are you doing this question?
So the side पे आंसर लिखा है.
उसमें yes, हाँ, उसमें we have to torque or kinematics. Both dynamics and kinematics we have to use. Right, guys, both dynamics and kinematics.
Yes.
Guys, इसमें जो है how did they calculate कि find the angular speeds के लिए उसके लिए क्या किया? Omega 1 and omega 1 dash and omega 2 dash is the final angular speed, and when the final angular speed are there, there will be no friction. Friction बंद हो जाएगा, मतलब there will no slipping, so there kinetic friction बंद हो जाएगा. So that means relative velocity zero. Relative velocity zero मतलब इसकी जो final velocity like this इसका इस side and इसका इस side जो है. So this speed जो है say इसका omega 2 dash और इसकी velocity इधर, तो ये वाला जो है omega 1 dash into r1 omega 1 dash into r1. Kinetic friction zero, relative speed zero into r1 is equal to omega 2 dash into r2. So this is the first one. फिर जो है टॉर्क फ्रिक्शन का आएगा, ठीक है, फ्रिक्शन का टॉर्क F into r1 हो जाएगा और दूसरे के लिए क्या होगा F into r2. So एक के लिए अपोजिट होगा और दूसरे के लिए ये हो जाएगा. और फिर गाइस एंगुलर इंपल्स एंगुलर मोमेंटम थ्योरम से क्या लिखेंगे? एंगुलर impulse is torque into time. See, torque into time is change in angular momentum. Torque into time is change in angular momentum. फिर उसमें जो है you divide, t eliminate कर लो, and omega 1 dash, omega 2 dash. You have two equations. You can solve them. इसको divide करेंगे तो guys see, when you divide this, you'll get this equation. And also you have this equation. Correct guys? इन दोनों से solve हो जाएगा?
Yes.
Okay. Yola, everybody understood? Students, Yola, please ask किसी को doubt. Ansh?
No.
Okay.
No, sir, no doubt.
Okay. चलो फिर ये वाला करते हैं. I mean ये mains मतलब guys वो advanced ही है, हाँ, it is advanced, not mains, subjective question. So you have two heavy metallic plates 90 degrees to each other. Okay, they are 90 degrees to each other. Laminar sheet. So बीच में जो there is a sheet, or the sheet is free to move about the hinge line AB. Axis AB हो गया. The hinges are frictionless. The moment of inertia of the laminar sheet about an axis parallel to AB and passing through center of mass. Okay, center of mass के through दे दिया है 1.2. Two obstacles are there. और like guys we have now, जैसे घर पे we have now walls पे रहता है, like there are stoppers so that the door doesn't bang on the wall. So that
Yeah.
like we have stoppers there, door stopper like that. The two obstacles P and Q are there, fixed, one on each metallic plate at a distance of 0.5 meters from the line AB. So guys, ये वाला 0.5 meters, ये जो है, this is 0.5 meters. Okay, 0.5 meters from the line AB. The distance is so this is chosen so that the reaction due to the hinges on the laminar sheet is zero. Guys, hinge reaction is zero. Hinge reaction is zero.
So RX.
Yes. So hinge reaction zero. The एक concept we can apply. Which concept? Reaction conservation of linear momentum. Okay. So hinge reaction is zero during the impact. But जो है hinge का reaction zero रहेगा, but stoppers जिससे जो door bang करेगा उसका reaction तो रहेगा ही. Okay. Initially the laminar sheet hits the obstacles with an angular velocity of 1 radian per second and turns back. Guys, ये door stopper हुआ और ये door गया, door say this is our door गया, door stopper को hit किया and turns back. If the impulse on the sheet is this, so अपन को ये calculate करना है. Okay. So guys, how will you do this one? Linear impulse, linear momentum theorem.
Yes.
Okay. So पहला concept, linear impulse, linear momentum theorem. So guys, linear impulse, linear momentum theorem से impulse आएगा, impulse वो जो door stopper का आएगा, okay. So door stopper का impulse जैसे जो है will be negative, opposing. So minus कितना दिया है, impulse is 6. Impulse is equal to final minus initial. So ठीक है guys, finally ये उल्टा आ रहा होगा, right? This will come back. और इसकी speed कैसे लिखेंगे, omega into r. Final angular velocity you don't know, omega f. Center of mass का distance we don't know, r. तो speed हो जाएगा omega into r. और initial वाला को momentum है ना, तो mass से multiply करना पड़ेगा. Guys, what is the mass here?
1.
Mass of the laminar sheet
30 kg.
30 kg. Okay, 30. So this is the final वाला negative side में आ रहा है उल्टा. Okay. And initial वाला, okay, initial वाला कितना हो जाएगा 30. Speed, initial angular speed given है, angular speed is 1.
100.
Radius, center of mass का distance पता नहीं है, r. So एक equation तो ये आ गया. So ये क्या आएगा guys, इसमें जो है minus we can remove. So we can guess, we can get here 6 is equal to, oh no, 30 omega f plus omega f r plus, या 30 से divide भी कर देते हैं, तो क्या जाएगा इस 30 से when we divide?
1 by 5 is equal to W of
1 by 5 is equal to omega f plus
Plus
1
R.
into r.
Yes.
Omega f, because see you'll get 1 by 5 is equal to omega f r plus 1 r. r common ये हो गया. बस ये तो एक इक्वेशन आया है. सेकंड इक्वेशन कहां से आएगा? Second equation guys. Laminar sheet, fringes are frictionless, axis इतना, और जो है we can use angular impulse, angular momentum theorem. Okay, so angular impulse, angular momentum theorem. So guys, क्या angular impulse, angular momentum theorem में angular impulse किसका आएगा? Linear impulse into distance. Linear impulse is how much? 6. Guys, distance कितना था? 0.5. Okay, this is 0.5. और moment of inertia कैसे आएगा? Half I find minus होगा, agreed. How will you find the moment of inertia about this AB? Center of mass के about पता है ना? Oh yes.
Yes, 1.2 kg.
Okay, so moment of inertia will be how much? Center of mass के about 1.2 plus
So plus mass
30
into
into
distance.
r, distance
So-
square, into omega. Initial omega is 1. Okay, so ये तो हो गया final वाला. Initial वाला minus initial वाला क्या हो जाएगा? 1.2 plus 30 r square. Initial angular velocity was 1 here. तो ये इक्वेशन कितना आएगा गाइस? ये वाला. यहाँ पे कुछ तो मिसिंग है. ओ फाइनल एंगुलर वेलोसिटी तो कहाँ पता है? ओमेगा एफ. फाइनल वाला इज ओमेगा एफ, इनिशियल वाला इज 1. ओके, हाँ, ये कितना हो जाएगा? इस माइनस भी हटा देते हैं 3, और यहाँ पे कितना बचेगा? 1.2 प्लस 30 r स्क्वायर ओमेगा एफ माइनस, यहाँ पे क्या आ जाएगा?
1.2 plus
1.2 plus 30 r square plus,
WF
plus,
minus
plus, plus.
1.
into 1. Okay. So guys, यहाँ से इन दो इक्वेशन से how will you solve omega f and r? Omega f and r, how will you? Oh हाँ, इन दोनों में guys ये common हो जाएगा ना? See?
Yes, a WF plus 1 will be common.
Yeah. So what equation we'll get from here?
But
3
3
is
is
equal
equal to 1.2 plus 40 r square into W.
into omega f plus 1.
Yes,
Now यहाँ से omega f plus 1 की जगह क्या लिखेंगे? 1 by 5r.
1 by 5 r.
So 1.2 plus 30 r square और ये कितना आ जाएगा? 1 by
1 by
5 r. Now you have to find r. R की value
Yes,
okay.
so
1.2 30 r square divided by 5r. So we have to take this to other side. This will be
the
how much?
quadratic.
15r. Yes, 15r is equal to 1.2 plus 30r square. Okay, guys, ये वाला quadratic आ रहा है. Please check कितना आंसर आएगा. What they have given r.
So you get it has 0.4 and 0.1.
0.4 and 0.2.
1. 0.4 and 0.1.
0.4 and 0.1. Okay. 0.4 और 0.1. वो दोनों satisfy कर रहे हैं क्या? Oh. 0.4 and 0.1 both are satisfying. Uh, Zero point 4 and 0.1.
Yes, so the sum of rows also combined.
Okay, so 0.4 and 0.1 both are satisfying. तो कौन सा लेना पड़ेगा यहाँ पर? And why? Center of mass. Okay, किसी एक में फिर which value will satisfy? क्योंकि किसी एक में ऐसा तो नहीं है माइनस आ रहा हो. दोनों satisfy हो रहा है.
Yes, sir. So even if you check sum of roots and product of roots, it's coming right on.
Oh.
So maybe quadratic only is
Quadratic is wrong, yeah? Okay,
maybe
1.2 30 r square, 1.2 plus 1 30, ये तो ठीक है, minus minus सबका cancel. This is also correct. ये distance भी correct, okay. And what they have given answer?
so 1 second. So for which exercise was
Oh, this is JE1. JE का JE वाला last में होगा questions. 29th question.
so 0.1.
0.1 it is given.
Yes.
Oh, 0.1 given है 0.4. यार अरे 0.4 में सेटिस्फाई होगा क्या? देखो अगर 0.4 डालते हैं, फर्स्ट 0.1 इज सेटिस्फाइड, यस 0.1 सेटिस्फाई हो रहा है, 0.4 डालते हैं, 15 इंटू 0.4 क्या होगा? 6 हो जाएगा। ओके, और ये वाला 30 इंटू 0.4 स्क्वायर
4.8 plus 1.2
हाँ वो भी सेटिस्फाई हो गया। हाँ, सो 0.1 सेटिस्फाई हो रहा है एंड 0.4 को नेग्लेक्ट कैसे करेंगे? इज देयर एनी अदर डेटा गिवन? मोमेंट ऑफ इनर्शिया अबाउट द सेंटर ऑफ मास इज दिस। सेंटर ऑफ मास का डिस्टेंस आ गया हमारा 0.4 आ रहा है, 0.1 सेटिस्फाई हो रहा है, 0.4 क्यों है? टू ऑब्स्टिकल्स, अब हिंज का फोर्स देखना पड़ेगा ना। हाँ, तो हिंज का फोर्स कैसे हिंज का सपोज hinge का how will you select? Impulse is equal to change in linear momentum. और अब इसके लिए जो है how will you reject 0.1 यानी 0.4? साइज ऑफ द प्लेट तो कुछ दिया ही नहीं है ना? नो, हाँ, the center of mass is closer here. If we take center of mass beyond this point, यहाँ पे फेल हो रहा है।
Yes, so both are not.
ये वाला कैसे सेलेक्ट करोगे? इसमें इज जीरो, लैमिनर शीट की वजह से जो है ये जीरो आ रहा है, हिंज रिएक्शंस, सो हिंज रिएक्शन जीरो। ठीक है, अब इसको जो है पॉइंट एनी अदर वे?
So we can calculate omega. If it turns out to be negative, then we can reject it.
Yes, Anya, which one you want to calculate? The negative part किसका किसका?
So we can calculate omega. So for 0.4, it is
Oh.
coming as negative.
वो 0.4 के लिए नेगेटिव आ रहा है। ओके ओके
Yes, sir.
ओके ओके ओके, ठीक है। 0.4 के लिए it is coming out to be negative. ओके ओके, सो आरफ एक सॉल्यूशन उसमें ओमेगा नेगेटिव देता है, इसलिए वी आर रिजेक्टिंग। हाँ, ओमेगा ऑलरेडी अपन ने उल्टा तो मान लिया है ना? तो ऑब्वियसली डोर जो है स्टॉपर को हिट करने के बाद इट विल टर्न बैक, इट कैन नॉट गो द सेम डायरेक्शन, राइट? मतलब इट कैन नॉट
Yes.
लाइक ब्रेक द वॉल, सो इसलिए उस बेसिस पे रिजेक्ट कर रहे हैं। सो ठीक है, 0.1। ओके ओके, थैंक यू आन्या। ओके गाइस, फिर आज इतना ही करते हैं, देन विल कंटिन्यू इन द नेक्स्ट क्लास।
Yes.
ओके स्टूडेंट्स, हाँ, थैंक यू ऑल, बाय। हाँ, थैंक यू गाइस। हाँ, थैंक यू आन्या, वेरी गुड।
Thank you, sir.
थैंक यू स्टूडेंट्स, बाय ऑल।
Bye, sir. Thank you.
Bye, sir. Thank you, sir.
बाय अंश,
Bye, sir.
बाय गाइस।